It's coming. No, I'm not doing it, man. It's not lying to you. There's nobody else. Last week was kind of a down week. We did all that progress monitoring. The week before that, we started looking at functions. Like AU, we looked at method diagrams, tables, graphs. Is it coming back to you a little bit? Yes, ma'am. All right, well, if not, this one take us back to it. So a linear function. A linear function is a graph of a function that makes a straight line. What does it make? A straight line. The name pretty much speaks for itself. Linear, it got a line in it, so we're looking for something that makes a straight line. It told us there's a constant rate of change between any 2 points. If given an equation, what did it tell us we need to do? Substitute values for x, then what? Graph, and finally, check for a straight line. Remember, linear function, that's what we're looking for. Does it make a straight line? Equation form, we should recall y equals mx plus b, or y equals mx. You forgot? The M represents that rate of change. It can be found using a formula. Anybody remember that rate of change formula? All right, go y2 minus y1 divided by x2 minus x1. You may want to squeeze that on the side somewhere. Oh. That's the rate of change. Initial value is the b. It said it can be 0 if it crosses at the origin. That's this equation. Y-intercept is 0 because it isn't there. Or it could be another value if it crosses at another point. A key piece to note in that middle. So the linear equation should not have a what? Exponent. It should not have an exponent. So if you ever see an exponent and they asking you if it's linear or non-linear, it will be non-linear. Linear functions do not have an equation. I mean an exponent. At the bottom, they give us tables of ordered pairs. What do they tell us we need to do? Plot the point, and then check for, once again, we still checking for that straight line. And then they said they give us a scenario to check for what? Mention of a rate of change. They'll use the words per hour or per feet, something of that nature. And then last but not least, check for that initial value. What's another name for rate of change? No, what's another name for the rate of change? So I would have scenario. Substitute. Slope. Don't know that. Squeeze that in there. Another name for rate of change is slope. What's another name for initial value? At the origin. That's our y-intercept, because it's where it crossed that y-axis. So if you got that, definitely squeeze that in there. We're going to be using that information to help us out in determining if these functions are linear or non-linear. Okay, you got some I need. Come on, girl. Oh, I'm supposed to make it. I was in the front. All right, real quick. This handout is about our 8 mathematical practices. If you ever looked up here and wondered what the pink things are around our board, those are our mathematical practices. We just gonna review it so that you know how to put it on their microphone and see you. So if they ever ask you about it, so that you will get some understanding of it. This one, you can barely kind of see it, but it was some little Lego blocks showing you how they all piece together. We're gonna look at the right hand side of it. So the first one says, make sense of problems and persevere in solving them. What's the student friendly language? Good job. Persevere means that even if it's hard, I'm gonna keep trying until I eventually reach solution. That means I don't give up. So we gotta get in the habit of not giving up with math. Persevere. comprehend regardless of how hard it may seem. Number 2 says reason abstractly and quantitatively. What we say to the side?
I can think about the math problem in my head.
That's when Ms. Ketchum first asked you after we read a problem to identify the keywords and information. If you cannot do that, we already do not know where we start. Number 3 says construct viable arguments and critique the reasoning of others. What's the side?
I can call a strategy to solve the problem and discuss other solutions.
What part of that is there when Ms. Ketchum has to do with that?
Solve the problem and discuss other student strategies too.
That's that part where I have us to explain. On the answer B, how you get there? That's that part, being able to construct viable arguments and critique others. Can we identify when somebody else is correct or incorrect? The 4th one says model with mathematics. What's the side?
I can use math symbols and numbers to solve the problem.
That's when the sketch is telling you do what?
Every day. So you work.
Show your work. It ain't just because I love it. It's because this is one of these mathematical practices, and we just need to know how can I set it up. So if I see it again without a calculator, I still have an idea of, oh, I do this. Number 5 says use appropriate tools strategically.
I can use math tools, pictures, drawings, and objects to solve the problem.
Any problem that has any model, common sense will instantly tell you, read the model and see if you understand what's going on. That also includes tools, like a ruler. If I need to use a ruler on the test, I gotta know where to start it at, how far do I stop, just like a protractor. If I'm using advertising, so anytime we have any tools, we gotta know how to use them strategically if we plan to get the correct answer. Number 6 says attend to precision.
I can check to see if my strategy and calculations are correct.
And what helps us do that?
Calculator.
Calculator. That's why I'm constantly telling us to check our work. Yes, and we big on showing it, and I tell us every time we tap, we should be writing it down as well. But definitely make sure we check that work. Some of us be making those small mistakes. And had you went back and checked, you would have found it before I saw it. Number 7 says look for and make use of structure.
I can use what I already know about math to solve the problem.
That's what Ms. Kelly said to him. What do you know? How are we going to start solving it? That's when I tell you to flip back in your notes, find the steps, and we should use those steps until we reach a point where we no longer have to use it. But if I still need it to help me to solve that question, I'm going to use it every day. But by the end of the year, hopefully I won't have to use it. And the last one says, look for and express regularity in repeated reading.
I can use the strategy that I use to solve another math problem.
That's why I have us to take note of the standards for bell work. So that you can start to notice that those same types of questions are solved the same way. When I give you steps, it's because every time you see that problem, it's going to be solved the same way. So we didn't have to especially notice them about this. So I did put holes in. Put in your math notebook. Whenever we do a math boundary check, that'll be one of the things I look to see. The back gave you some other ideas about using those particular taxes, what it look like and things of that nature. So just a good resource to better help us with math. Everybody should have everything on the board by now, correct?
Yes, ma'am.
So you got a big head.
She said, you didn't know that? I know I feel big. We got it. I've been doing it. You believe that about two. All right, now. I want to make them new.
Okay. All right, I am giving you grid paper. It got several grids on the front. On the front as well as the back. I did not print the one with numbers because sometimes we don't always count by one, sometimes we count by other different numbers. But we all should be familiar with the coordinate plane and how it works. All right, so we gotta look at this question.
write the question down?
No, you don't have to. We only write the problem for bill work. But we're gonna be getting different pieces. All right, so the first part of it says, use the equation y equals 2x plus 1 to complete the table of values. Use the equation to complete the table of values. And I'm gonna stop right there. How can we use this table, this equation to complete this table? The note said do something. If they give us an equation.
If given an equation, substitute values for
What now?
substitute values.
All right, now notice the values they gave us for x. These are also my favorite numbers for x. You remember me from last year, I always stuck with -2, -1, 0, 1, 2. Because that gives us at least 2 negative numbers, the origin, to see where it's going to cross at the y, and then we get at least 2 positives. So get in the habit of making sure if you have to substitute, you want at least 2 negatives, 0, and at least 2 positives. These are always good ones to use. All right. So our equation is 2x plus 1. That means every time we see x, we're gonna put that first number. So I'm gonna rewrite it with this one. The first x is -2, so that'll be 2 times -2.
0.
4. -4 plus 1. Good job, -3. So every time you see x, Shantasia, that's what you put in that number over there. So now 2 times -1. 2 times -1 plus 1.
-1.
-1.
I said that.
Now I gotta remember, if I was to put this on a number line, what does plus mean? Going the other way or that way. And then we just said to attend to precision to use what? The math practice said attend to precision. We said that helps us to do what? Or what allows us to do that? By using my what? So that means if I still can't do these integer calculations with positives and negatives, make sure you got your calculators going back and checking behind. 2 times 0 plus 1. Good job. 2 times 1 plus 1. And then 2 times 2 plus 1.
5.
Take me 5 seconds to show how I'm going to substitute that x in and then put my answer right there. 5 seconds. Any questions about it? They give you an equation, get you some x values, and substitute. It don't matter what x value, but those are my favorite. All right, the second part of that said use the table of values to make a graph. How do we make a graph? Good job. So if we look at that table, we know it's x and y, so that'll be our first point. -2, -3. You can find it on your first graph. -2 on the x that she told us, and then go down 3. Then we got -1, -1. It is little, I apologize. But I was trying to get rid of one where we got several on the page. Okay. That way if you get at home and you see a needed one. All right, 0 is at 1. So it didn't go across on the x, just went up. 1, 3. Then 2, 5. Every line is one number on yours. If you put your numbers for these will help you out, you can. And kind of mentally know what that number is, that'll work as well. Or just be like this. And what do you think we're gonna do after we plot? We're gonna connect the points and then we're gonna check to see if it can make a straight line.
It's kind of crooked.
It looks a little crooked based on how you got it on there, but it should be a straight line. So then that last thing asks us, does it represent a linear function?
Yeah.
Yes, because
It makes a straight line.
it made a straight line. Oh, lamb. It's just that simple. Yes, it's a straight line. I connect the point. Like, let us know how you know that it's linear. Questions about it. So if they give me a table, what am I to do? Substitute, put it in the X. After I substitute, then do what? Graph it on the coordinate plane, and then I'm checking for what? If it made a straight line. Good job. Not a limit. Question? Everybody got it? You said, hold on. I thought someone said, hold on. Uh-huh. Because I ain't got it up.
Can we wait for him to see us?
Oh,
Hey. You got his camera on. You're supposed to have your camera on. He need to put his name in the camera. Right. Yeah.
and then mine keep popping on mine.
Girl.
All right, so the next one we're gonna look at. It says the cost of a school photo package includes $40 for the photo shoot, plus the number of photos ordered multiplied by the price per photo. And then I want to know, is this situation defined by a linear function? Before I continue reading, let's think about what they told us. What did they tell us? $4. Okay, 40 for the photo shoot. Photo multiplied by the price per photo.
That's like why. Because it's like a normal there. Why two?
No, you thinking of slope form. But linear formula is the first one, right? Because MX plus B. And what two things did we say we need?
Oh, hold on.
The what? Rate of change. Rate of change and initial value. So based on that scenario, we got $40 for a photo shoot, and then the price per photo. Rate of change, what's the 40 for the photo shoot? So yet again, I'm gonna ask you, is it a linear function? Yes. What's my rationale? What you just tell me?
Yes.
Okay. It has an initial value of 40 and rate of change, price per photo. All right. Second part of this. They now said, predict the answer that we already predicted. And it said, write and graph an equation. Write and graph an equation. Okay, they said we use 250 as the price per photo or any other value. You want to use it as the price per photo?
Yeah, we can use $3.
$3? Okay, so what would be our equation?
$3 plus
Good job. Y equals 3x plus 4. All right, so after we get an equation, what we need to do?
solve it.
Substitute. All right. Now we said in that table about how many numbers we need. And don't forget zero. So 5 numbers. 2 negative, 2 positive. Watch your table said, and don't forget 0. Give us 2 negative.
-1, -2.
That'll work. She said -6. We're gonna go with -6 and we'll do -1. We'll do 0, give us 2 positive.
-6, -4,
5 fifths. So many. All right, choose another graph. We're gonna substitute and then we're gonna graph. So let's substitute first. 3 times negative 6. Negative 18 plus 40.
40 is
larger, so I know it's gonna be positive. Not 32.
22.
All right, 3 times negative 1 plus 40. So that'd be 40 minus 3.
Which is 37.
Okay. 3 times 0 plus 40. 3 times 5 plus 40. 55. 55. All right, 3 times 6 plus 40. All right, so those are our numbers. Now notice nothing is drawn on there with numbers, so we can come up with our own numbers. I ain't gonna say come up with our own numbers. We're gonna count by ones with your x-axis. It should be enough to go over to 6 and beyond 6. Now think about that y-axis. Looking at our answers, what might we need to count by? 5. You got 2. What's gonna run out of room if you say 2? 1. We ain't got enough room to go up and down to 58. 10.
58. They not all. 58 divided by 4. I said they not all positive. 58 divided by 4 though.
That's not all positive? I said the what you see a negative at?
That's the board, right?
We said y. Oh, my bad. We said the y-axis. We already said the x-axis we're gonna count by 1.
14. Count about 14.
Now 14 be too much. We're gonna count by 10. So the y-axis we're gonna count by 10s. X-axis we're gonna stick to 1s. So that means every little line that's gonna be 10. I know it's small on your paper. You can either write it in or write it above it so you know you count by 10.
You know what? I'm just gonna put that on the side.
That'll work.
Sure, it's fine.
The x-axis we just gonna count normal by 1. Go ahead and find your graph. You're gonna model this problem. You can label it or you can write it below it that we count by 10 so that you know. You're gonna have to connect your points. If you haven't already done so, you're gonna have to connect those points after we graph. All right, so go ahead and attempt to start graphing. Woo. Base time is gonna be kind of tight, so we count by 10. All right, so negative 6 went to 22. That'll be close to 20, but a little bit above 20.
Okay, hold on. What's the first thing?
Negative 6.
22.
Uh-huh. It's a little bit above the 20.
I'm lost.
Where you lost it, baby?
Okay, you said count by 2.
Not on your x-axis, count by 6. On 1. 1, 2, 3, 4, 5, 6 on your x. And then go up by 10. All right, the next one was negative 1 at 37. Close to 40, but not at 40. 0 at 40. 5 at 55. In between 50 and 60. And then we got 6 at 58, close to 60, but not quite there. Then afterwards, connect the points. It may be a little off like mine because I didn't use the actual grid.
So either or not is long.
No. I just said mine is off because I'm not on recording plane. Watch yours and see if it matches up. And then since we didn't count by 10, it's varied.
That turns out like yours.
It's straight.
Got a little curve somewhere.
All right. And we know it should be linear. Why?
It's somewhere straight.
It's somewhat straight, but what else tells us it's going to be linear? The equation. Our equation is in equation form, so we know it's going to be linear. Our graph is off. Mine due to it not being exact. Yours due to it's so small and you probably couldn't get quite exactly. But as long as we know it as close to it as possible. Questions? You sure? And get in the habit of connecting all points. Some of you not connecting your points, get in the habit of at least trying to connect them so you can clearly see. Everybody good? I'm gonna give you about 1 minute to have a look at this problem. I said read this. That means you already got the answer?
That was the talking about my head. Oh, Miss Casey, can I really cut the class? On the board, by linear form. I agree with Georgia.
Why you agree with George?
Because even though it is a negative rate of change, it's still a rate of change.
Okay.
And it's gonna be a straight line.
Okay.
You guys are down.
So Emma said it wasn't linear. Georgia said it was linear because it's in the form. Carla said we agree with Georgia because it is a straight line.
And the equation is the equation function.
And the equation is an equation form, linear equation form. Good job. All right, one way to help you determine your slope outside of the equation. If they give it to us on a graph, always look left to right. Notice on this one, left to right is going down, so we know it'll have a negative slope. If it's increasing from left to right, it'll have a positive slope. You might want to draw that on your paper somewhere. Going down left to right, negative. Going up left to right, positive. You at least have 1 or 2 questions where they just gonna ask you, okay, which one have a positive slope and which one have a negative slope. So I need us to be able to look at it and tell. Always start at the left and move down. Left and move across. It'll help us determine if it'll be positive or if it'll be negative. That should be
that should be, what you call it when you come to answer the question? That should be fluent.
Fluent? Questions like this?
That's what I'm supposed to.
It's on who?
Now I'm asking me to do it on.
Okay, I can make that. I can make that happen. I'll make that happen, Kenzie. She said she don't. She don't want it. I can give you about a minute.
But no, it's not an equation because we got x from
Yep. Oh yeah. I didn't think about what you said. You said it's not an equation.
It says it's not have an x from. Well, we got not a linear function. I gotta think. It said it should not have an exponent. Yeah, it's probably yeah.
All right. So she say no, not linear, and then that'll be my explanation because it has an exponent.
You know, technically, boy. What? I said these notes.
That's why I said you get your notes. That's all we look at. And then we use them until we don't have to use the notes anymore. But yes, it got an X on it. So I'm glad Kennedy went back and corrected. Just because it's not a linear function, does that mean it's not a function? No. So it is a function, it's just not a linear function. So make sure we know the difference between a question asking us if it's a function and if that question is asking us if it's a linear function. Pay attention to that. Questions about it? Well, we're gonna have at least one where they're gonna try to throw in and see if it'll throw you off. I cut it off.
Yeah, you cut it off in my list. That's how you think. That guy, you're not like this, right? To see what she had us watching today. Oh, me. People. It was sad, though. It was really sad. Y'all, since the board recording this.
He not on you.
The board recording us. We not on you.
Are you okay?
Cornelius.
Girl, shut up.
I got the
What you think?
So I think it is a
Y'all agree with this?
Yeah.
All right, so that will be our first response.
It's on going up, ain't it?
Well, if it's going up, what that mean?
I think you tell if it's going up or down.
Right there, it's like high. Go from left to right.
Okay. It's going
All right, so she said it's a linear function because it made a straight line. Quite a few of us telling us that it has a positive slope. All right, and then that last part asks us, how can we write an equation?
from left to right. Why is X to, oh no, it's from.
All right, now let's stop and think. You said it's linear. How should an equation of a linear function look?
Oh, y, I know. Y equals mx plus b.
Good job. What two things do we need? Initial value. So looking at this graph, which one can we find first?
The rate of change.
Y initial value. What is that initial value?
The y.
So that's the first place to look. Look on that y-axis, go down, that gives us that y-intercept, which is what?
3.
So that point would be 0, 3. So we can come over here. I found the y-intercept to be 3. Now, if you recall 2 weeks ago, we said with slope of rate of change, we need what? 2 what?
2 positive numbers and 2 negative.
That's what it takes. Slope. 2 what?
2.
You thinking about the table too?
Square roots have 2.
I think it's coming back to square root. Slope. Last week, the week before last with slope. Did I put it up there?
Oh, that's it.
Rate of change, I got the ratio of x and y, also known as slope. Ooh, right there in pink. Can be found using what? 2 points in the formula. So remember, I did that thing. I find the slope by finding 2 points. But before I can do that, Penny, I gotta get my second point. But yes, that'll be the formula that we're gonna use. Negative 2, 0. Good job. That'll be the x intercept. So make sure to remember with slope that y-intercept. Not only is that y-intercept, it'll also give us another means of getting one of those points. So then I'm gonna just find another point. It's easier to find your x-intercept, and notice it's the x-intercept, so that value will be in the x. Pay attention to that. All right, when we talked that, I also told us we can label it. So that'll be X1, Y1, X2, and then Y2. That way, when you start substituting in your formula, you don't have to put one. What was Y2? What was Y1? I'm gonna just look over there and find it. So if you still not labeling, please do so. What's Y2? That's why I said do what? Did you label them? You put on your paper and you label? Come on now. Y'all gotta know how to work with this slope formula without me. 0 minus 3. And then the X. -2. Good job. 0 minus 3. And -2 minus 0. -2 minus 0. Did I go anywhere?
0.
Oh. I'm still at -2. Good job. I'm still at -2. Negative and negative makes it a positive. So there'll be a positive 3/8. So I find the slope, I find the 2 points. I use slope formula to get 3/8. What will our equation be?
2
Okay. Y equals 3/2 X. That's the slope. Plus 3. Good job. Now notice that formula always says Y equals MX plus B. If it was down below, that B would be a -3. So make sure we know that plus B can either be positive or negative based on if it's above the X or if it's below. Pay attention to that. Questions about it? Sure?
I'm gonna go home and study tonight.
All right, they want us to predict whether or not these will be linear functions or not.
I know X
Okay, give them 1 minute. Go ahead and have a look.
We said we not like some other things.
We smart.
Number 7 is
What tell you is limit? So when you see this on homework in your bi-weekly this Friday, I expect the same stuff. Yes, it's linear. It's in the form y MX plus B. No, it's not linear. It got an X from it. And that way you just circle something, you go about your business because you know I'm gonna come through and just give you what. I don't know. We gotta either get a 0 or a half point. So something as simple as that. You say what? Because I don't know where it fell from. I don't know where it fell from. See it in the sky, and then it ain't in your brain. Teaching is all about me kind of knowing what's in that brain, and I only know what's in that brain based on what you show me. So something as simple as this. I need an explanation over there. I have from 4 to 5 every week who be missing them material, and I be like, she made a 50 again. And I keep it moving because y'all know me. I try to be fair with all my students. If I say show it, just put it. All right, this one said use the equation y equals x cubed to complete the table. X cubed. What that cube mean? Multiply 3 times. -2 times -2 times -2.
Oh, you want us to solve it?
-8. And it's still negative because it was 3 on good. -1 times -1 times -1. And if you need to write it out so you can see to help you with those negatives, if you in person, please do so. I'd rather you do that and get it right than not do it and then it wrong. 0 times 0 times 0. 0. All right. All right, so then find -2. You can count by ones. There should be enough room for your X and Y to count by ones. -2, -8. -1, -1. 0, 0. 1, 1. 2, 8. And then don't forget to do what? Connect those points. Somebody said it's cricket.
It is cricket.
Is it linear?
No.
So we would say not linear. It's not a straight line.
At all. Look how easy this was.
And then we already knew it was not linear. What? It had an X on it. So the graph was just there to kind of help you determine if you guessed correct or not. But if it got an X on it, it's not linear. Is it a function?
No.
Well, that's what I said on the function.
It is, but it's not a linear function.
Yes, it's not a linear function. It is a function, so we can slide across and we ain't touching no points other than one at one time. It's just not linear.
Mine look like a V.
A what?
Boy, I think I did it
Nah,
right.
you better check your points. Yeah, you need to check your points. So the 1 and 8, they were negative and positive. They weren't the same. You got a quadratic function with a 12. I'm just saying if it has a, all right, so there's something else. If it has an exponent of a 3, it's going to look somewhat like this. If it has an exponent with a square, it's either going to curve like that, or it's going to curve at the bottom, or it may curve to the sides. They want to add that in there just to, that's different when you get the algebra. They start giving you all kinds of stuff. You 4 and 5 in here, I expect to see a 4 and 5 in there. You got it. Here, you got it. You got it. All right, get your stuff situated. All right, Cornelius, that's all we got for today. Hopefully, you understood what we were going over and all of that.
Yes, ma'am.
Homework will be posted tonight. It's the same 3 questions as always. Take your time on it. Show us what you learned, and then hit submit. Have a good Monday.
You too.
Now,